I say node which is capable of holding certain item or an element, then we will be calling that as a node here. Root node always doesn't contain any parent node. It will be a parent for its successor nodes. The successor of parent node is considered as what? Child node. It can have more than one child. If I consider this node I as a parent node, then it will going to have two children called M and N. Hello everybody, a warm welcome to one and all. Welcome to the first session of your chapter 2, and we are in the unit 3 of B.Ca's second semester, subject called data structures using C. So in this chapter you will be learning regarding this trees concept. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So in our today's session, we will be learning regarding trees data structure. As I discussed in the first session of this data structures using C, there we got to know that we have different types of data structure, right? Primitive, non-primitive. Under the primitive data structure, we have integer, float and all. When it comes to the non-primitive data structure, there we have a linear and non-linear. So this trees comes under non-linear data structure. So when it comes to the non-linear data structure, at the time the elements or item which will not going to be arranged in some order. So it will going to be arranged in some other tree-like structure, or it can be a graph. So there we are learning regarding this non-linear data structure. Amongst that, one of the example is regarding this trees. So we're going to see what do you mean by trees and what are the types of trees we have. And at last, I will be discussing regarding this tree terminologies. That means it will going to give the definition of some of the terminologies which is necessary in order to understand the trees concept. So we'll see the first topic here, that is regarding trees. If I simply say trees, what comes to your mind? You are just going to imagine root will be there, leaves will be there, some fruits will be there, right? So those are the things which comes to your mind. When it comes to the data structure of this tree, it is a data structure consists of nodes. We are going to call that as a nodes. You will be understanding what do you mean by nodes, what is leaf node, what is root node, everything that I will be discussing in my coming slide. As of now, you need to understand this tree is also a data structure, and it consists of nodes organized as a hierarchy. So here it is not organized in a linear manner, or it is not organized in some order. We are arranging the nodes or set of elements as a hierarchy. If I say hierarchy, then you need to remember it will be like this, right? So hierarchy in the sense it is a tree-like structure. This you are going to learn right now. It is a data structure which is collection of 0 or more nodes. So there can be no values or no items, that is 0, or it can also have some of the nodes and also finite set of directed lines called branches that connect the nodes. If I wanted to have a connection between the different nodes, then we require edge. Edge is also considered as what? Branch. So we have a branch, we have a leaves, we have a root. So all the normal terminologies with respect to the trees also going to be there in the tree data structure. It will be a collection of one or more nodes. Along with that, in order to communicate or in order to transfer the data between different nodes, we need something in between in order to connect those two nodes. For that reason, we have some directed lines, whether it is what bidirectional, unidirectional. So we are going to have certain directed lines. Then we are calling that as a branches that will going to connect the different nodes. So these are all the branches. Then what are the types of trees we have? So we have two different types of trees. One is general trees and another one is binary trees. So now we'll have a look regarding this general trees now. So here you can just see the example. All these are what? Nodes. We have different nodes and each node is having certain items or elements. For example, if I consider this in the linear data structure, how it will be? Like it can be array, it can be linked list, queues, or it can be stacks. So all these elements will going to be arranged in this manner, isn't it? For example, A, B, C, D. It may be like this. If I am following the array data structure, if it is stack data structure, then it will be like this. If it is queue or a linked list. So we know how to represent the data in the linear manner. But when it comes to the trees, it is like a hierarchy. So here we are going to have different nodes and each node is carrying certain values or items. So here you can see that first we have a root, which is the topmost node of a tree data structure is considered as root, and also we require edges in order to make a communication or a connection between the different nodes. We require this edges, and also we will be learning regarding all these terminologies in my coming slide. First, we'll see some of the tree terminologies now. First, I have a node. If I say node, which is capable of holding certain item or an element, then we will be calling that as a node here. So here, node is a fundamental part of a tree. So each tree will going to have n number of nodes. There is no restriction of having only 5 nodes, 6 nodes, not like that. So we are going to have n number of nodes and it will be considered as a fundamental part for a tree, and each element of a tree is called as a node of a tree. For example, if you consider A, B, C, D, all these are the elements or items. So all these are elements or item. So in order to hold that, we require one node that is considered as what? Node of a tree. I hope you understood the first terminology, that is regarding node. We'll see the next terminology, that is root. So then what do you mean by root here? Already I mentioned that root in a previous slide, right? So this is the topmost node of a tree. If I consider a tree, it can have any number of nodes which is at top, then we will be calling that as a root node. Then if you consider this example, what is the root node or which is the root node here? That is A. A is considered as a root node. Why? Because it is at the top. The topmost element or a node or item of a tree is considered as root node. Important, all these terminologies are important. Next is what? Edge. Already you know edge, right? That is what? Branches. Why we require that? It connects two nodes to show that the tree is a relationship between them. So in the trees, we will be using this edges in order to make a connection between the different two nodes. Here you can see that we have n number of edges here, right? In order to have a communication between the different nodes, we require this edges or branches. Edge or branch. So next is what? Parent. So usually to whom we are going to call as a parent. That means it is an immediate predecessor of a node. So if you consider this example here, A is a parent of B, right? Because this B, for this B node, A is a predecessor. That means which comes before the node of B. So if we are having, do we have any parent node for this A? No. Why? Because A is considered as a root node. Root node always doesn't contain any parent node. It will be a parent for its successor nodes. So here, for B node, A will be the parent node, and for E node, this B will be the parent node. That means immediate predecessor of a node is called as what? Parent node. So here you can see that C will be the parent for this G node and H will be the parent for this L node. So for this, if I consider a node L, then which is a predecessor for this? That means which is at the higher position than this L? That is H. It's derived from H. That's why this H is considered as what? Parent node for this L. Fine. We'll see the next terminologies here. So here you can see the same example. I will be using the same example to make you understand all the terminologies. Let me move to the next one, child. So who will be called as child usually, right? So a successor of a parent node is called the child node. So if you consider this example, so already you know about a parent node, right? So this, if I consider this D as a parent node, what are the children it has? So it includes H and I. So here H and I are the children for this D. So that means the successor of each node in a tree is considered as what? child. So it can have one child or more than one child. That is what children here. So if I consider the node I, if I consider this node I as a parent node, then it will going to have two children called M and N. And if I consider the N node, it doesn't contain any child. So we are going to call that N node as what? Leaf node or a terminal node. That I will be discussing in my coming points here. So as of now, you will be understanding the successor of parent node is considered as what? Child node. It can have more than one child. And whom we call as a siblings here. So usually what is siblings? So children of a same parent is considered as sibling. Here also same thing. Nodes that are children of a same parent are called siblings. So if you consider this example here, HI are the siblings of a node called D. Why? Because H and I both are a successor of a same parent called D. And if I consider this E and F, so these two are the siblings for the B. That means E and F are the siblings and that has the same parent called B. So B is a parent node here and successor is E and F. And if you consider J and K, those two are the siblings because for J and K, they have a same parent called E. Fine. This is what? Sibling child. Next, what we have here? Leaf or terminal node. And it is also considered as what? External node. Nodes that do not have any children or a child are called leaf node. So, if you consider this example, consider J, K or you can consider G, L. Do it contain any children? That means, do we have any successor here? No, right? That means terminal node or leaf node or a node which do not have any child or a children, then we will be calling that kind of node as what? Leaf node or a terminal node, and also we are going to call that as a external node. So as of now, the examples are what? J, K, and also for F we can consider because this F doesn't contain any successor here, and also G, L, and we can take N. I can't take M. Why? Because it has one child called O. So that is what the reason we can't consider M as a terminal node. This N is also considered as a terminal node or external node. Why? Because it doesn't contain any of the child or a children here. So these are the some more terminologies with respect to these trees. So next we'll also see some of the terminologies. Next we have a internal node. It is just a opposite to external node. So if it doesn't contain any child or a children node from tree, then we are calling that node as a external node. If it is having a child or a children, then we will be calling that kind of node as a internal node. So here a node has one or more children is considered as what? Internal node. So here you can see the example. If I consider C, this will be the internal node. Why? Because it has a child called G. And if I consider D, this is also internal node. Why? Because it has two children, that is H and I. If I consider I, these also considered as internal node. Why? Because it has two children called M and N. I can't consider F. Why? Because F doesn't contain any child or children. That is why we can't consider this as a internal node. It will be a external node. Okay. A node which has one or more children will be considered as what? Internal node. Next, what do you mean by path here? Path is a way. So, way from where? Path is an ordered list of nodes that are connected by edges. So, if you consider the path, so how can I reach from A to O? So there are some other ways we have in order to reach, right? So what do you mean by path? Mainly, it is an ordered list of nodes. Ordered list of nodes that are connected by the edges. So let me consider the example. I wanted to reach from A to O. How can I reach? What are the nodes that I am supposed to visit in order to reach this O? Let me take, I wanted to have a source called A. From here to here, I need to reach. How can I reach? What is the path for this? So I need to come for A, then I need to come for D. After D, then I need to move for I, right? Then from I to M and M to O. So this is just a path in order to reach I to O. Fine. This is specifying a path. So how can I reach L from root node? That is also possible, right? I will start from A, that is root node, then D, then I need to come for H, then from H to L. This is also one more path. This is how we are going to specify a path. That means it is an ordered list of nodes. We have a set of nodes which needs to be visited in order to reach a specified node that are connected by edges. So if you consider the example, here also we have edges, right? So with the help of this branches or edges, we are connecting this node from the root. Then we will be calling that way of reaching from here to here is considered as what? Path. What we have next? Height. So what do you mean by height here? The height of a tree is defined to be the maximum number of nodes in a branch of a tree. So what is the maximum number of nodes that we have in a branch of a tree? Will be considered as what? Height. And we are also going to call height as a depth. What is another name for height? That is depth. That mainly specifies the maximum number of nodes in a branch. If you take this example, what is the height of this particular figure or a tree example? 1, 2, 3, 4, 5. I need to take the last branch, or I need to consider the last terminal node in order to find the height. Okay. 1, 2, 3, 4, 5. So the height of this tree is 5 now. Height of this tree is 5. Fine. These are some more terminology. We'll see the next terminology, that is ancestor here. So whom we call as an ancestor? A node reachable by repeated proceeding from child to parent, then we will be calling that as an ancestor. So if you consider this example, who is the ancestor for this M? Who are all the node, or which are all the node which we have as a parent to this M? That is I. If you consider I, for I it will be D. For D it will be A. So that the ancestor of a node called M, then it will going to include I, D as well as A. Let me consider one more example, K. So overall the ancestor of this node called K, we have E. So for E we have a B as a parent node, and for B we have a as a parent node, right? So from child to parent node, who are all the proceeding node that we have, then we will be calling that as a ancestor node. Fine. Next we have a descendant here. So descendant in the sense what? The nodes which are coming next. That is what? The nodes in the path below the parent are called descendant nodes. So a node reachable by repeated proceeding from the parent to child. It's just the opposite to ancestor. So when it comes to the ancestor, it will be from child to parent. But when it comes to the descendant, it will be from parent to child. The path from the parent to child will be considered as descendant. The path from the child to parent is considered as ancestor. That is just a reference between ancestor and descendant. Fine. So if you consider this node called C, what is the descendant of this C? That is G, right? So if you consider A, then it will going to have B, C and D. Fine. This is how we are going to find the descendant. That means the proceeding node of a parent node from the parent to child, then we will be calling that path as what? Descendant. Then what do you mean by subtree here? Subtree is a set of nodes and edges comprised of a parent and all the descendants of that parent. Then we are going to call that kind of tree or a mini tree as a subtree. Then you can find out here how many subtree we have for a root node called A. So we have 3 subtree. One is B and another one is C and other one is D. So when it comes to the subtree, it will be a parent node along with all its descendant. The descendant in the sense parent to child until the leaf node. So then this will be one T1 or subtree 1 and this will be T2 and this will be considered as what? T3. So T1, T2 and T3 are the subtree of this root called A. So it's all about these 3 terminologies here. We'll see some more terminologies now. So here we have a level. What do you mean by level here? The distance of a node from the root is called the level of a node. If I wanted to reach any of a node, how can I reach to root? What is the distance between the root to that node? We are calling that as what? Level of a node. So always the root will be at the 0th level and the next level or a child of that root node will going to be considered as what? Next level, and always the level of any other node is 1, then that will be more than the level of its parent. So if you consider the children, they will be the next generation. So if you consider the grandchildren, they will be the another second generation. So if you consider the example here, always the root will be at the 0th level, right? It will be at the 0th level. This will be the level 1, this will be the level 2, level 3, and at last we have a level 4. So then what is the level of this I? That is 2. Why? Because in order to reach this root, we require or we need to visit 2 more levels. So that is why the level of this node I is considered as 2. If you consider this example, what is the level? So this one, 1, 2, 3. So this will be the level 3. So the path or a way or a distance from the root node to particular node, then we are calling that as a level. Fine. So next we'll see the degree of a node. So degree in the sense how many branches we have, that specifies the degree. The number of branches associated with each node is called a degree of a node. So we'll see the example. What is the degree of a node called C? How many branches it has? It has only 1 branch. So that the degree of a node C is 1. So if you consider the B node, what is its degree? It has 2 branches, right? 1 branch and 1 more branch. So that the degree of a B is 2. And if you consider the K, this is external node. It doesn't have any child or a children. So the degree of this node K is 0. Fine. So next, we have a out degree branch. So when a branch is directed away from the node, then we can say that as a out degree branch. So here all these are a non-directed trees or a hierarchy. So if I am making like this, let me consider. So here the branches are away from a given node, then we are calling that as a out degree branch. So if it is coming like this, then it will be, if it is coming towards to the node, then we'll be calling that as a in degree branch. So when a branch is directed towards the node, then we will be calling that as a in degree branch. So it is moving away from the node, then we are calling that as a out degree branch. So all these are the important terminologies that you need to learn when it comes to the trees concept. Fine. So it's all about our today's session. I hope you all understood. It's regarding the chapter 2 of your unit 3. In my coming session, we're going to have a last chapter of a unit 3, that is binary tree. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.